You're on mute.
Welcome, everyone, to the AWS Nordics Office Hours. Things can happen when we are live. So this is the weekly show from the Nordics where I bring on guests to talk about techie stuff. And this time we started out by talking about audio, apparently. Every week, I have an AWS expert on to talk about a specific topic, and you, our viewers, are able to then ask questions around that topic. And hopefully by the end of the hour, you've learned something new, and also you've been able to get a lot of questions answered. So feel free to start using the chat. Let us know that you're here and that you're watching. And this week, I'm joined by our old friend, Alexander Dragunov. So welcome back, Alexander.
Thank you.
So great to have you with us again. We've talked about .NET, we've talked about CDK, and this time we're gonna combine the two, but even add some additional things to that. But first, tell people a bit about yourself if they haven't watched you on the show previously.
Yeah, so good afternoon. My name is Alexander Dragunov, and I worked at AWS as a partner solutions architect, and I'm specialized in Microsoft workloads on AWS, and especially in .NET on AWS. So that's why, again, the topic of today's session will be something around .NET, as before.
Exactly. And well, tell us about the topic of this week then. What are we going to spend this next hour on?
Yes, so what we're going to do today is to build end-to-end CI/CD pipeline for .NET 5 application. So we will build it from scratch, and we will do it like in less than an hour, obviously. So we will use code commit, code build, CodePipeline, CDK to create .NET 5 web application and deploy it to Elastic Beanstalk. And the Elastic Beanstalk environment will be itself created by CDK. And again, it will be end-to-end demo from scratch in less than an hour. So this is our goal for today.
Very cool. And the entire suite of code tools, I guess we'll go through them one by one as we get to that section of the demo when you're building the application. And CDK, that's something that we've talked quite a lot about on the AWS Nordics Office Hours, but let's cover some basics there as well when we get to that point. So, well, where do you want to start, Alexander?
So we will start, as I said, we'll start from scratch. So we need a place to store our source code. So we'll start with code commit.
So, all right, your screen share is up. Let's go.
Okay. Yeah.
Tell us about code commit to begin with.
So code commit, it's a way to store your source code, and it's just a Git compatible repository on AWS. So everything that you can do with your Git repository, all your Git commands were just applicable to code commit. So convenient way for you to work with your Git repository on AWS, I would say.
And that means compared to using other Git providers, it means that you're storing your source code within your AWS account.
Yes, exactly.
Right. So let's get started then.
Yeah. So as you see, I don't have anything in my account. So let's start with creating a repository. And to make name fancy, it will be live demo.
Yeah.
That's it. The repository is created. Now we need to access it. So I'm just cloning the URL, and it looks like this: git code commit, and then region, and this is name of my repository. And I will switch to my development environment, and this is standard command to clone repository. Clone, and this is the URL which I copied.
Do you ever see anyone using SVN these days instead of Git?
It was a long time ago I used SVN, so I think nowadays everyone is using Git.
Yeah, seems to be the de facto standard today.
Yeah. Okay, so yeah, I just cloned empty repository, so I need to add some file to it. So I will just I will switch to main branch. And I will just fetch readme file and then standard commands. Git add, Git commit. So as you see, nothing proprietary, just standard Git commands. Okay, so now my README should be in our Git repository. Let's switch and see our repository code. And yeah, you see, we have our README in our code commit repository. Okay, so, but the goal of the session is to create ASP.NET Web application. So let's create it. And let me grab some piece of code, not to type it. So I'm just scaffolding standard web application using .NET new command, and the name of application will be sample app. It's very easy. Now we will .NET will restore some packages, and to make it more to add some touch of this live demo, I will just change a name of the application. So it will be where's my page? So instead of welcome, it will be AWS Nordics Office Hours. So you see that it's not, so it's real demo. And let's run this application just to see how it looks like. But it's standard scaffolded .NET Framework application.
And this is using .NET 5?
Yes, it's .NET 5. So everyone, I guess, is waiting for .NET 6 to be released. It's preview 1, but for now, because it's preview, we will work with .NET 5 because it's a released version. And let me show how our application looks like. Yes, standard application and AWS Nordics Office Hours. Okay, so this is the application which we're going to deploy to AWS. Okay, but now this application, it's a local one. So now we need to push it to repository. But before we push it to repository, we need to later tell how to build this application. And in order to do it, I need to create a file which is called buildspec.yaml and add some content to this file. And I will show it in a second. So this is my buildspec.yaml. So this is the first version. So this file will evolve during today's session. But here what we are saying that I need .NET 5 runtime. Then I specify build command. And for build command, I'm just using .NET build. And then I'm specifying post build command, .NET publish. And it will publish it to output folder. So this is actually the name of this output folder, which I'm specifying as an output artifact. So this is simplest version of Buildspec YAML for .NET 5 application.
And this is used by code build.
It will be used by code build, and I will show it in a second once we introduce code build to our pipeline. And then I need to also add gitignore file because now I don't want binaries to be included into my project.
And the gitignore file is used to choose basically what you're able to commit into.
Yeah, or what I want to exclude actually. I want to commit everything except these files which are generated by build. So you see now it's going to commit 100 files, but once I save this file, it should be 54. So I don't want any generated binaries to be committed.
So a question from the chat, what does the file buildspec.yaml do?
So buildspec, it will tell build agent how to build this application. So first it will compile it, .NET build, then it will publish it to output folder, and then we specify like what artifacts to take from this output folder. So this is like the result of build process. Take the sources, compile it, and put the binaries into output folder. And this is what we specify in this buildspec YAML. But later you will see like how this file evolves, like when we add CDK, when we add unit tests, so you will see like more and more lines in this file. But for now, build, publish, and specify where the artifacts are. Okay, so now we need to commit all our changes. So again, git add with all files, commit application, and push it to main branch. And there is one more thing which I need to do is to create an S3 bucket to store the artifacts, because when we create our code build, we need to specify where to put the binaries. So for that, I will just going to create a S3 bucket using AWS CLI. And as you know, the bucket name should be unique. So let me name it like this. And I hope this name is unique. Yeah. Okay. So we created the bucket. Then we have all our sources in code commit. Yeah, so we have sources, we have build spec, we have git ignore. So next step is to create build project. And in order to build a project, we're going to use code build. So let's get started. Again, create build project. And it will be named sample app.
And how can we simply explain what code build does?
So code build, so we have source code, and source code is just C# files in our example. So we need someone to compile this code, some agent. So we need some environment for this compilation process to run. And this is what we do with code build.
Yeah, simple as that.
So sources. You can use S3, you can use GitHub, GitHub Enterprise, Bitbucket, but in our case, we're using code commit. Repository, this is the repository which I just created. I'm picking the main branch because this is what I want to build. And then I'm next time need to specify the build environment. So like where I want to, how this build machine should look like. You can use your own custom image if you have very specific build environment, but I'm using managed image. I'm going to use Ubuntu with standard runtime with version 5. And then it's going to create new service role for me. And then for our builds to be a bit faster, so probably we will spend a couple of minutes. I'm just using different compute instance instead of two CPUs.
Tell us why you chose to use Ubuntu in that case.
It's because .NET 5 is not a long-term support version. It's it's available like on Ubuntu platform, and let me find a link where the runtimes are specified. Just a second.
I can paste that in the chat.
Yeah, but yeah, I will show it here.
Yep.
Yeah, so this is available runtimes, and for .NET, if I want to use .NET 5, I need to use Ubuntu Standard 5. If I use .NET 3.1, which is long-term support version, I can use either Ubuntu or Amazon Linux too. But for .NET 5, this is what I'm using, and this is what I configured. Standard, Ubuntu Standard 5. And then instead of 2 vCPUs, I'm using 4 vCPUs. And then how to build it, I said that I'm going to use build spec file, but instead I can have build commands specified here as well, like one by one. But we're going to rely on the build spec file, which will be part of our source code. And for artifacts, we're going to use S3, and this is the bucket name which I just created. So once the build process is done, all the binaries will be put to this folder. And I think that's it. Create build project.
And there's a question in the chat around prod or dev, different environments or stages. If you can have an auto trigger for the dev environment and manual trigger for prod. And perhaps this will be shown better in a later stage when we get to the pipeline?
Yes, so CodePipeline, it's a service which helps you to orchestrate build process. And in CodePipeline, you can have like different branches for different environments. So you can orchestrate your build process with CodePipeline, and we will come back to it in a few minutes. Okay, but now build started. So as you see, build is ongoing. So
what it's doing now is it's setting the runtime based on the build spec,
yes,
fetching the artifacts.
yes, and then doing the compilation process, and you see the whole output here. And restoring NuGet packages, and then uploading artifacts to S3. So upload is succeeded. So I suppose in a second it will be succeeded, and we can see that our S3 bucket is not empty anymore. Any moment soon.
Well, it's always the case. Yeah, so what you entered into the build spec file is what's being used by this code build project to then do the different steps that you've defined.
Yeah, okay, so succeeded, build details. And this is my artifact folder location. And yes, this is the application, and this is the binary folder with all published binaries required for this application to run. Okay, so we have our source code, we have we have our Git repository set up. Now, what we want to trigger build every time we push changes to this source code repository, because you saw before it was manual process. I just clicked the button, trigger build, and then my artifacts were created. And to do it, we're going to CodePipeline. So we're going to create pipeline and name it sample app as well. Create new service role. Okay, so we're specifying code commit again, and like how I can explain it, why we're specifying it again. So here we're specifying when do we want to build. So we want to build when something is changed in this repository, in this branch. And before, when we configured the code build project, I would say we specify like what we want to build. And here we specify when we want to build. So we are using code commit, we are using this repository, this branch, and we it will be triggered based on CloudWatch events.
So every time there is a commit to your code commit repository, there is a CloudWatch event, and that in turn will then trigger.
Yes, and it will trigger this pipeline. Okay, so we specify what is the source, or like what is the trigger. Now we specify build provider, and we can use either Jenkins or code build. So we're using code build, and this is our project name, which we created 5 minutes ago. For deployment, we will skip deployment stage because we need to create infrastructure first, and yeah, let's skip it. And that's it. Let's create pipeline.
There we go.
Yes. So, and it's automatically triggered because yeah, there is a new commit from CodePipeline perspective.
And a pipeline, if people are unaware of what that actually means, how would you explain what a pipeline is?
It's a kind of order of steps that you want to perform. So this is first step, get the sources. This is second step, build it. So
pretty much the easiest pipeline there is.
Yeah. So two steps only.
And going back to the question from earlier, you would then add additional steps based on your different environments, for instance, and just define how you want those steps to proceed.
Yes, exactly. Okay, so while it's building, let's add unit test to our project. And I will switch to the console. So, okay.
There we go.
And again, it will be a simple XUnit test project, which we name sample test. And it's scaffolded, I think, one unit test. So if we run .NET test, you will see that one test should be, one test is passed, all green. This is how it should look like. Now we need to update build spec because we need to specify that we want to run these tests as a part of our build process.
And what do you? This is just a basic test, but what do you usually include in unit tests for different kind of projects?
It's it's just based on your needs. Unit test, which it's a test for your project, for you to know that you should proceed to the next step in your pipeline. But everything is good. Okay, so I'm just modifying the build spec, and I will show what is changed. So it's only two changes. So there is a second command after .NET build. We are running .NET test. So if a build is succeeded, we are running these tests. We are specifying the format of a logger. It's TRX, and we specify the output folder for the test results. So this is one line which was added to the build spec, and the second one we added this reports section where we specify that we want test results from this folder, and this is the Visual Studio TRX file format. So,
and I think that this shows even more clearly now in the build spec file what it actually does. You're adding an additional command to run that unit test that you just defined.
Yeah.
And you could basically just copy paste that command and run it yourself as well, right?
Yes, exactly. So it's standard .NET command. There's nothing build spec specific, nothing AWS specific. Okay, so let's commit it. And again, if we switch, so our previous build succeeded 2 minutes ago, and now because the sources are changed, it should automatically trigger next build with unit tests. So let's see, any second now. Yeah, so it's triggered with sources with commit, which we just did with unit tests, and now it's building. But instead of only building of application, it will also run the unit tests. So let's wait, I guess about 1 minute.
Yeah, question in the meantime. Basically the cost for code build, how does that work?
So it's a pay as you go model, as most of AWS services. So you pay for per minute for the build agent when the build is run. So in our case, like if our build was run for 2 minutes, I will pay for 2 minutes of build agent time. And then there are different build agents with different compute power from 2 vCPUs to, I think, 36 vCPUs, or there's even build agent with GPU. So based on the instance size of this build agent, like the price per minute will different. But you pay per minute for build agent.
And that's really one of the great things about a service like CodeBuild, that it spins up the instance or the container that you're running your build project on, and then it spins down. So you only pay for the time that is active.
Yeah, and also another good thing about CodeBuild that it runs like in a new Docker container every time. So meaning that your build environment is immutable. So if you build something, the build was succeeded, next time the build failed, this means that it's not something with your build environment and something with your source code. So
That's
that's
right.
okay. So the build is succeeded. Now if we go to details, to reports, so we should see our one unit test passed with
Yep.
100% pass rate. Okay, so now we have our source code, we have our build process, so application is successfully compiled, it's tested, we have artifacts. Now we need to deploy it somewhere. So we need to define our Elastic Beanstalk environment. So we need to create our infrastructure project, which we will use to deploy this code. And to do that, we are going to use CDK.
And do the quick intro to CDK, what it is.
So CDK, it's a way for you to build your infrastructure, but not using YAML or JSON files, but using your favorite programming languages. And in my case, we're going to use C# to create the infrastructure. And under the hood, it will be compiled into CloudFormation template, which will be deployed using CloudFormation provisioning engine.
But if you don't prefer .NET, you could use Python, TypeScript, Go, I think.
Yes, F#, Java. So
Java as well. That's right.
Most languages covered. Okay, so I'm running CDK init command and I'm specifying C# as a language because we're talking about .NET today. So, and then I need to install a couple of NuGet packages for Elastic Beanstalk. So first package is Elastic Beanstalk. And the second one will be for IAM because we need to create some policies and instance profiles. Let me paste it. And yeah, IAM. And then I will copy a piece of code, which I will explain later.
And the packages you installed, they contain the constructs that CDK uses to define the infrastructure.
Yes, exactly. And because we're going to use, we're going to create environment for Beanstalk. I installed constructs for Beanstalk and for identity and access management. So let me switch to Visual Studio Code. And also, as you see, we have our project structure. So we have source code, and next to our source code, we have our tests, and next to it, we have our infrastructure. So we really working with infrastructure as code, which is side by side with our application. And this is what was generated by CDK, but I'm going to paste this 50 lines of code, which I will explain. So first, we are creating an instance role. So we need to specify a role for the instances which will be used by Elastic Beanstalk. And we are attaching managed policy Elastic Beanstalk web tier. Then we create instance profile with this role which we just created. And then we specify some options for Elastic Beanstalk. So first we're specifying instance type. So we are going to use T3 small instances. And we're specifying instance profile, which we just created, which is based on this role, which we just created. And you see like all these references. And then we create an application and we create environment with this application name and providing the settings. And also we want to ensure that application is created before environment. So we're saying environment depends on application. So basically that's it. This is how we create our Elastic Beanstalk environment using C# code, and this is it's much easier to read and understand comparing to few hundred lines of YAML code. And
this was, how many lines was this, you said?
So it's
50?
51, but including some usings, namespaces, classes. So like actual code, I think it's 40 lines of code, even less.
Let's take a look at the output of the CDK to see how many lines of CloudFormation is created as well when we get there.
Yes, let's see. CDK synth to be in folder which contains CDK.json to run CDK commands. I think this is a folder. CDK.json, which says how to build this application. Let's run CDK synth. And in meanwhile, we need to make also changes to our build spec to build this CDK project. So let me switch to build spec, and I will add a few more lines of code, which I will explain. Okay, now it's a bit longer, but so what we do here, first we are running npm install because CDK is written in TypeScript, so you install it using npm. So we're installing AWS CDK because it's not available on our build agent. That's why we're installing it. Then in order to build it, we are using this CDK synth command. So we built our .NET project and we test it, and then we synthesize a CloudFormation template. And then we have these secondary artifacts. So instead of our application, now we have like both application and our CloudFormation template. So we define two set of artifacts. One we called CloudFormation, which has this template which was generated by CDK, and then our application itself. And if we go to CDK, so our 40 lines of code, it's ended up being 300 lines of code. So again, this is the power of CDK. So you write the code in your familiar programming language, and it end up being 300 line of code of JSON template generated. Okay, so we created our CDK project. We updated our build spec file. So now let's push the changes to our code commit.
So now you're pushing the CDK part of it to the same repository in this case?
To the same repository, and we haven't added any new build steps. So the output of this stage is just that after the build, we created both binaries for application and the CloudFormation template generated by CDK. So next step would be to deploy this CloudFormation template to AWS.
Right. While that's building, if you just joined us, this is the AWS Nordics Office Hours with me, Gunnar Grosch. I'm joined by Alexander Dragunov today to, of course, talk .NET and to talk CDK. And through this hour, but I'm just watching, to be honest. Alexander is building an application from scratch, taking us through the build process, how to actually deploy it into AWS as well. If you have any questions, post them in the chat. Alexander is here to answer them, and I'm here to just read them out loud.
Yeah. And so what's happening now, our build agent is just proceeding our build spec file. So first it compiles the application, it runs unit tests, it runs the CDK synth command to compile our CDK project and to generate CloudFormation template, and it puts it into two sets of artifacts. One with CloudFormation template, and this is the output, and the second one is application binaries.
So when you work with CDK, perhaps locally, you would perhaps do the CDK build command as well to then start creating the infrastructure. But in this case, that hasn't happened yet.
No, it's done by the CDK synth. So
yeah,
what CDK
it's creating
synth does,
the template, but not building the infrastructure.
Yeah. So and CDK synth, what it does based on the CDK JSON file. So for .NET applications, it will tell that just .NET run, and this is the C# project of CDK. So this is what CDK synth does actually under the hood. Okay, let's see if it's okay. Build succeeded. So now we have our CloudFormation template generated, our code generated. So now it's time to deploy it to AWS. So we're going to edit our pipeline. And first we need to specify that our code build, it actually has two sets of artifacts. So it has application and CloudFormation. And these were the names which I specified in the build spec: CloudFormation and application. If I hope I haven't misspelled it. That's the most dangerous thing in a live demo, when you misspell something.
Yep.
Okay. Done. And then we're going to add a stage, and let's call it infra. And what this stage will do, we're going to use CloudFormation as an action provider. Input artifacts we're going to take from CloudFormation. Action will be create or update stack. This is the name of the stack. And this is the artifact. So this is the template which will be used by this CloudFormation. And it's called infra.json. So this is the file which was generated by CDK. So artifact name CloudFormation, infrastack.template.json. Then I need these capabilities. And then there is a role which this is the only thing which I created before. So this is IAM role, which gives CloudFormation permission to deploy artifacts, to deploy the stack. Okay, so I hope that's it. So we're using CloudFormation artifact, update the stack, using this file, and using this role. Done, done, save. And because we haven't changed the source code, we will just click release to release this pipeline. Because
so now it reruns the pipeline with the same source artifacts as last time?
Yeah, same source infra. So it will run it again, but this is the step which we are interested in to deploy our CloudFormation template. And this will take maybe 3-4 minutes. So if we have any questions.
There was a question around Java that's answered already. I also posted a link to the CDK documentation so you can see what languages are supported as of now, and also how to get started using AWS CDK. Next, there was a question around how many AWS services we're using in this case. And since all of these services, they are part of the developer tools, but they all have their very specific use case, and they're doing just that. In the end, there are quite a lot of services involved, but they all work together. So we're using code commit, code build, and CodePipeline so far.
Yeah. And also, as you can see, there is a code artifact and code deploy. So if you want to publish your inside organization, if you want to have your private NuGet repository, for example, you can use code artifact to host this private NuGet repository. And code deploy, it's the service which is used to deploy your applications to Elastic Container Service, to Lambda, or to EC2 instances. So we're not going to use code deploy because we're using Elastic Beanstalk as our target, and it's a managed service. But if you want to deploy to EC2, then you can use code deploy. Or if you want to create canary deployments to Lambda or to ECS, again, this is something you can easily configure in code deploy.
You can even use code deploy with on-premises instances as well.
Yeah. Okay, so now you see that this CloudFormation is deployed. So if we switch quickly to CloudFormation, so we will see that this sample app stack is now deployed. So this is the, and if we go into it and see template, so this is the CloudFormation template, which was generated by CDK, which is now being deployed. Okay, so it will take a couple of minutes, I think. And I think this is the longest step in the pipeline to deploy the CloudFormation for the first time.
Yeah.
But the next time, as we are not going to do any changes to our infrastructure, this step will be very fast. So it's
in that case,
it's either create or update the template, and we haven't done any updates to the template.
Right. Right. So right now it's creating everything that you defined in your CDK application with the instance roles and the Elastic Beanstalk application.
Yeah, and we can watch progress here as well in CloudFormation, because under the hood is just deploying this template to CloudFormation. Or CloudFormation is deploying it.
Right. All right. In the meantime, if you have any questions, post them in the chat. Alexander is happy to answer any questions around .NET, even though it perhaps doesn't have anything to do with this specific demo. Question: what happens at deployment failure? Complete stack rolls back or only failed step?
And we are now talking about CloudFormation, I think.
Yes, I would say so.
I think the default behavior that it will fail and it will roll back, as far as I remember. And this is about this step. So like the build step, it will be as it was before.
That's right. So it doesn't affect the previous steps in the pipeline. This is handled separately.
Okay, so let's check the output. Okay, so this is the default Elastic Beanstalk environment, because we haven't deployed our application yet. We only created infrastructure. So this is the target Elastic Beanstalk environment, which we're going to update with our application. So now it's deployed. And yes, and if we go to CodePipeline, it's already deployed, so CodePipeline just hasn't realized it yet. Let's take as deployed. Yeah, okay. now it's successful. So what we did, so we have our application, we have our infrastructure, we deployed our infrastructure, we have our application binaries. So the last step in the pipeline is to deploy our binaries to this environment, which we just created. So let's edit and add another stage, and let's call it deploy.
I just added a link in the chat about a news from CloudFormation from a couple of months ago, or 1 month ago, about how you can retry from the point of failure in a stack. So have a look at that.
Yeah, and so what we're going to do, we're going to deploy, and action provider will be Elastic Beanstalk. Input artifacts, this is our application artifact, which we defined as secondary artifact before. And application name, this is application which was deployed by previous step. And this is the environment. And actually that's it. Done. Save. And again, because we haven't done any changes to source code, we just release it manually. So this time it should be faster because this infra is already deployed. So it will check that, okay, no changes in CloudFormation template, and it will go to this deploy stage. So again, we have a couple of minutes, I think.
Yeah. So now it will compare the new CloudFormation template to the one that was actually deployed previously. But since there aren't any changes, it's going to be fairly quickly, that part.
Yeah. And this is, and the URL of load balancer will not change because again, we haven't changed CloudFormation template. So this magic random number will not change. So we'll just, once everything deployed, we'll refresh this page and hopefully we'll see our application there. But again, let's wait.
Yeah, the build time is usually the one that takes time during these demos. All right, so if things go as we hope now, when we reload that page after this pipeline is done, we should now see your .NET application running from that Elastic Beanstalk environment.
Yes, exactly. And we're still on time. So as I promised, it should be a live demo end-to-end in less than 1 hour.
Yeah, that's good. Come on, code build.
Yes, when I do it myself, I think like code build is like super fast. When I do it in a live demo environment, it's like, okay, why it's so slow? The time flows very differently what environment you're in.
Someone says that your clock says 4:35 a.m. I'm not sure where.
I think it's this virtual machine. So I'm using this.
Oh yeah.
So this is just a dev box with clean environment, which I'm using. So I think it's somewhere. Yeah, I don't know where it is.
So we just proved that this isn't a recording. It's just his virtual machine. That's.
Yeah, but you see this infra stack, we already passed it. So now the deployment is ongoing because we have no changes to infrastructure.
So what happens? Can you press the in progress? Where does that send us now? I'm not.
I cannot press it.
No. All right. So if we were using CodeDeploy instead for deployment to EC2 instances, for instance, we would be able to watch the progress. But in this case, I suppose we aren't.
I think it's hidden by Elastic Beanstalk.
Yeah. And that's kind of the point with Elastic Beanstalk, that you shouldn't have to.
It's managed environment, so you only need to care about your application and not about underlying infrastructure. So this is what I think great about Elastic Beanstalk.
Yeah. Question: if you're using Cloud9, but you were using Visual Studio, was that right?
I was using Visual Studio because I'm .NET guy, and I had like Visual Studio Code, and I have like full Visual Studio in my development environment. So that's why Cloud9 is perfectly fine, because now I'm just dealing with text files.
Yep.
So it should work with Cloud9 as well. Okay, so build is succeeded. Let's refresh it. And voila, I mean, our application is deployed.
Very
And
cool.
we can make one small change to deploy version 2 of this application, for example. If I go to sources, so we trigger full pipeline end-to-end.
Yep.
And my page, let it be version 2.
All right. So committing that to the repository, which would trigger the entire pipeline. So while that is happening, let's walk through the steps that we've done to get to this point.
So first step, we created our code commit repository. So this is where we store our source code. Then we created our code build project. So we specified what sources to build and how to build them. And how to build we specify using the buildspec.yaml file, which is also stored in the source code repository. And then we orchestrated the build using CodePipeline. So this is our source stage. This is what triggers the build. And the build is triggered every time there is a change in our code commit repository. When we build the sources using the code build project, which we created before. And then as an output of this build project, we have two sets of artifacts. One is binaries for our .NET application, and the second one is CloudFormation template created by the CDK. So we have this infra step, which deploys the CloudFormation template to the AWS account to create the target Elastic Beanstalk environment. And then finally, we created deploy stage, which deploys the binaries which we created as part of this build stage to the target Elastic Beanstalk environment. So end-to-end from sources to running environment.
And based on this setup right now, we could quite easily replace different parts. For instance, not everyone is a .NET C# developer, but you could pretty much do the same, but using any other language.
Exactly. So if we check how buildspec.yaml file works, so here instead of .NET build, it will be your Java C compilation step. And yeah.
Yeah. And if it's still building, what if...
Now it's deploying to...
All right, so it should hopefully be done fairly quickly then.
Yeah.
And in this case, you were using code commit, for instance, but the source could be, as you showed when you added that in our pipeline, it could be GitHub, it could be S3 or Bitbucket, and so on. So
yeah, so our version v2 is deployed. So if we refresh this page, okay, v2 is deployed. End-to-end pipeline.
Very cool. And built in under an hour. So now we built it with a very simple unit test that is green, it's okay, it works. What if a unit test fails?
So if unit test fails, then this build will fail. So meaning that we are not going to proceed to infra and deploy stack. So let me quickly break it, because that's the most exciting part, to break something.
Yes.
So this is our test project and this is our test. So let's add another test. Test 2, we just throws exception, meaning that it will fail. And Let's quickly see what's happening.
And since the test is part of the build step, it will be quite quick to get to that point.
So this build step should fail in this case. And this is the purpose of unit test, not to proceed further if something wrong happens here.
Right. Right. And let's see.
Like 1 minute.
Should be quick.
Still on time.
Yeah. No worries. I have another question I want to ask, but I want to see this fail first. So
it's not something that you want to hear from a host. I want to see this fail.
Well, so I want to see when you make it fail succeed. So
yeah,
that was better. Come on, code build. Want to see a similar session to deploy to EKS, and yeah, it would be quite easy to change this into deploying to EKS instead. There's some different CDK setup, setting up a EKS cluster, and then
I think with EKS it will be even more interesting because you need to set up cluster itself with CDK, but also you need to manage application on the EKS cluster, maybe using CDK for Kubernetes.
Yeah,
so it could be interesting session. Okay,
definitely.
So build failed. This is what we wanted to see. And if you want to details to reports, you see that it's failed. And we see that we have one test which passed and one test which failed. And that's why our build hasn't proceeded further. So exactly what we expected.
Very cool. I like that the report duration is super exact in how long it took. Right, so now a unit test failed, and that means that it will stop the pipeline. The developers will notice, they will fix whatever is wrong, and then commit new code.
If you go to pipeline, so here's this failed test, but infra and our deployment is still on previous commit, which was succeeded.
Yeah, very cool. So the question I wanted to ask before, or rather bring to the discussion, is there was a comment early on in the chat about different environments with staging or testing environment and then prod. And you could easily add those different deployment options in this pipeline.
Yeah, exactly.
So set up different environments using CloudFormation or CDK, and then deploy to those one by one. And if you wanted to do it manually, which I think the question was early on, you could add a manual approval step in your pipeline as well, so that it won't deploy into production until you manually press that approval button. All right, 1 minute to go. You made it under the hour. Great, Alexander.
As promised.
Yeah, you keep your promises.
Demo gods were with us.
No, this was great, Alexander. Very interesting to see. Alexander has joined us and built and deployed a .NET 5 application to us in under an hour using the code suite of tools and CDK, and deploying that to Elastic Beanstalk. So thank you very much for joining us today, Alexander. Thanks to all of the viewers and for all of the questions and comments we got throughout this hour. Do follow Alexander on Twitter as well. His handle is shown on screen. And if you wish, follow me as well. Thank you all, and hope to see you again in 2 weeks. There's no show next week. Bye-bye.
Bye. Thank you.